Good day everyone. For this particular video, we'll be discussing about how the elements found in the universe were formed, specifically those that are lighter elements at the same time the heavier elements in our universe. So it started the idea of the Big Bang Theory. So this states that the universe started about 13.8 billion years ago from a very small, extremely hot, and very dense point, then expanded rapidly and it's still expanding today. So based on this idea, the universe started at a single point and it continued to expand continuously until today, where we can see different galaxies, different star formation at the same time, different planets in the universe. So what are the key ideas in the Big Bang Theory? Number one is that it has a beginning point. Everything like the space, the time, matter, and energy started from one tiny point called a singularity. So again, take note of the idea of singularity. It started with a single point, now based on this particular theory or the Big Bang theory. Number two, rapid expansion. There was no explosion in this particular theory, but in space. Instead, space itself expanded. So from a single point, very hot point, it continued to expand until today. That's the second idea of the Big Bang theory. Number three, cooling and formation of matter. As the universe expanded, it cooled. First formed are the protons, neutrons, and electrons. Then, after a few minutes, light elements like hydrogen and helium were also formed in a particular time. Number four, formation of galaxies and stars. After millions of years, matter clumped together due to gravity, forming stars, galaxies, and eventually planets in our solar system and the other parts of the universe as well. So this is the Big Bang Theory in a chart shown in this particular video or presentation. So here, the cosmos goes through a super fast inflation, expanding from the size of an atom to that of a grapefruit in a tiny fraction of a second, about 10 to the negative 43 seconds in time. Number two, there is post-inflation. The universe is a soothing hot soup of electrons, quarks, and other particles. There are formation of particles in this particular point in the Big Bang Theory, about 10 to negative 32 seconds, and about 10 to the 27 degrees Celsius temperature, which is very hot. Number three, a rapidly cooling cosmos permits quarks to clump into protons and neutrons. So the particles now started to clump together into protons and neutrons. That is about 10 to the negative 6 seconds and with a temperature of 10 to 13 degrees Celsius. And after 1 second, and 3 minutes. There is 3 minutes with a temperature of 10 to the 8 degrees Celsius, still hot to form into atoms, charged electrons, and protons prevent light from shining. The universe is a super hot fog. So because of very hot temperature, there is still no formation of atoms. Now from the different protons, neutrons, and electrons formed during step 2 and step 3 in this particular chart. And electrons combine with protons and neutrons to form atoms, mostly hydrogen and helium. Light can finally shine. This is about 300,000 years and 10,000 degrees Celsius, where electrons now combine with protons and neutrons to form what we call the elements, now forming the atoms in the universe. About 1 billion years and a temperature of negative 200 degrees Celsius in the universe, gravity makes hydrogen and helium gas coalesce to form giant clouds that will become galaxies. Smaller clumps of gas collapse to form the first stars. And lastly, about 15 billion years, and a temperature of negative 270 degrees Celsius. As galaxies cluster together under gravity, the first stars die and spew heavy elements into space. This will eventually form into new stars and planets. Now, so during these last steps, heavy elements were now formed in our universe. All right, let's continue. So the formation of light and heavy elements. The origin of all naturally occurring elements fall into two phases. We have here the Big Bang or the primordial nucleosynthesis and the stellar nucleosynthesis. What's the difference between the two? So when we talk about Big Bang or primordial nucleosynthesis, this is where the origin of the light elements started, or this is where light elements were formed during the Big Bang or primordial nucleosynthesis. And for the stellar nucleosynthesis, the origin and production of the heavy elements in our universe is through the stellar nucleosynthesis. And we will be discussing this one or these two in our next slides. So the light elements like hydrogen, helium, lithium, and beryllium were present during the initial formation of the universe. And as we mentioned earlier, it started with the Big Bang nucleosynthesis or the primordial nucleosynthesis. So, talk about nucleosynthesis. This is the process that creates new atomic nucleus from pre-existing nucleons, which is neutrons, I mean. So, we started here with a proton combined with a neutron, and we can now form our hydrogen with one proton and one neutron added in two. So, two H and one as our proton. This is our deuterium or deuterium. Bombard it with another neutron, and we will have one proton still that is representing our hydrogen and having two neutron. So this is now a triton or a tritium. And bombard it with a particle of proton, then we will have two protons now and two neutrons, and this is where helium is formed. So again, proton combined with a neutron, we have a deuterium, which is a heavier type of hydrogen. And then bombard it again with a neutron, then we will have a triton, which is another heavier isotope of hydrogen. And once it is bombarded with a proton, we will have now two protons and two neutrons, where helium is formed during this nucleosynthesis. So, what causes the neutrons and protons to combine and form certain species of atomic nuclei in a process called nuclear fusion? So, the answer here is extremely high energy and temperature of the universe. So, this causes neutrons and protons to combine and to form atomic nuclei in a process known as nuclear fusion. So, through nuclear fusion, the light elements, hydrogen, helium, and small amounts of lithium and beryllium were formed. So, we talk about isotopes. Take note of this particular word, isotopes. This is a form of an element that has the same atomic number of original element but with different atomic mass or mass number because there is a difference in their number of neutrons in their nucleus. That's why they have different mass number. So the same element having different mass number since there is a difference in their neutrons and protons located in their um, nucleus. So these are isotopes, I mentioned earlier. We have the proton, the deuterium, and the triton, or the prosium, deuterium, and tritium. So where every one of this is hydrogen. They are considered hydrogen because they have one proton, as you can see, but they have different neutrons. So for proton, it is only proton. There is no neutron. So it's one H1, one proton. This is hydrogen. For the second one is deuterium or deuterium. So we have here, as you can see in the chart, one proton and one neutron. So add them, they will become two. Um, Mass number is 2 inside the nucleus of hydrogen, but it is still hydrogen because it only contains one proton. For the third model, we have here one proton that is still considered as hydrogen, but now it has two neutrons in its nucleus. That's why 1 plus 2, we have 3 as the mass number. Still hydrogen because it has one proton. The same thing with carbon 12, carbon 13, and carbon 14. So all of which contain 6 protons, 1, 2, 3, 4, 5, 6, but different number of neutrons. Say for example, for carbon 12, we have here 1, 2, 3, 4, 5, 6. 6 plus 6, 12 as a mass number. For carbon 13, there is 6 carbon proton. So 1, the positive 1, 1, 2, 3, 4, 5, 6. And we have 7 neutrons. 1, 2, 3, 4, 5, 6, 7. And at the same time, for carbon 14, 6 protons, 1, 2, 3, 4, 5, 6. But we now have 8 number of protons in the nucleus. 1, 2, 3, 4, 5, 6, 7, 8. And that becomes 14, carbon 14 as the mass number. And since it is just a neutral element, there is no charged particle here, the number of electrons are just the same as the number of protons.